3.4b, we're continuing with solving equations. This time we are solving logarithmic equations. So you're going to notice that every one of the problems we do contains a log. And in order to solve for it, we need to remove the log. We cannot work with it. This is just a quick reminder that a common log has a base 10, but we don't have to write that. A natural log is a log with base e, and we typically write it as log of n. And one rule that you need to know is this. If you have a log with a base that is equal to a log with the same base, and there's nothing else in front of it or behind it right here other than just one term, then this here has to be equal to this. So n has to be equal to m. So the logs essentially simplify themselves away, and we're left with a simple equation. Now, just like solving with exponential functions where the unknown is an exponent, there are some strategies for solving logarithmic equations. If you have one log, you need to isolate the log. That's always your first step, whether it's logs or exponents, you isolate that. And then you're going to write it in exponential form. So you will remove the logs to get it in exponential form. If you have more than one log, you have two things you can do. First thing, you will condense, if you can. Once you condense, you're either going to do the first bullet point, get one log equal to one log, because then you can use that log of bn is equal to log of bm. So you could say n is equal to m that I just showed you, or you can go to step number one and write in exponential form. But in both cases, you need to condense the expression whenever possible. Okay, here's our first problem. First, you should look at these and ask yourself, do I have one log or multiple logs? If you have one log, you need to isolate the log with whatever it follows. So in other words, nothing can be added or subtracted in front of this. It is currently isolated. You're then going to move to the next step, which is to write it in exponential form. Exponential form's coming from 3.2. It is taking the base over to that as the power, and it is equal to whatever follows the log, and now your log is removed. We know 2 to the 4th is 16, and look at how easy this problem has just become. X is equal to 11. Now the catch is, it is absolutely necessary every single time that you check your answer. You must plug your x in, the value for x in that, and make sure that this results in a positive number. If it is negative, the answer does not work. Now 11 plus 5 is 16, it's positive. We could check it in our calculator, but as long as it's positive, it should work out. Now, if you take a look at this one, again, your first step is to see if you have one term of logs or two term of logs. If you have two terms of logs, you have two options. You can get one log equal to one log, or you can condense down and then write it in exponential form. So let's see if we can get this one log equal to one log. In order for that to happen, this has to be isolated on this side, and this log has to be isolated on this side. So in other words, that 2 needs to go someplace, and so does the 6. Well, if we use our power rule and put the square, make that squared, and make that to the 6th power, then what we have is this. It is x plus 2, the quantity squared, is equal to log of 2 to 6. Now, in taking a look at this, we have all numbers here. And anytime we have all numbers, we can evaluate this. If you don't know what this is equal to, which hopefully you can see the answer 6, because the log of 2 with base 2, that is essentially simplifies to 1 and leaves you with this as the answer, so it's equal to 6. But if you can't see that, remember, use your change of base function in your calculator. So under the math, and then a, which is log base or change base, something like that, change base, I think. And then you can plug that in. So now on this side, we have log of 2, we have the x plus 2, the quantity squared. Now if we take, and because we're down to one log, we can write this in exponential form. It's 2 to the 6th power is equal to this. And now we can evaluate this. 2 to the 6th power is equal to 64. And if I take this x plus 2 and I multiply it by itself, x plus 2, and FOIL that, I'm going to do it rather quickly, but what I'm going to get is x squared minus 4x plus 4. In order to solve something that has multiple terms of x's and there's an x squared, we have to get one of the sides equal to 0. So we're going to subtract 64 to both sides. And in doing that, we have this function, and we can now take and we can factor this. Again, factoring comes into play. XX, signs are the opposite, and it looks like I'm going to have 10 and 4, and oops, 6 rather, 10 and 6. Because this right here is negative 10, positive 6, so that gives me a negative 4x. Now I have two answers. I have x equals negative 6, and I have x equals positive 10. Now, while these appear to look like my two answers, I need to check them because remember, you cannot take the log of a negative value. So whatever follows right here has to be positive. If I plug in a negative 6 and add 2, I get negative 4. You cannot do log of any negative value. That will give you an error message in your calculator, so I have to throw this one out. When I plug in 10, I get 12, so that one's okay. So x equals 10 is my only answer. If on your test you forget to check your answers and you leave them both, you will get it wrong. Okay, and taking a look at this problem, you will notice there is only one term of log. One term of log means we need to isolate the log and whatever follows it. The 4 that's in front has to go away. To get it to go away, because it's multiplied to the log, I will divide both sides. That is going to leave me with this. Now, I can't solve anything with logs. I have to write this in exponential form. Exponential form starts with the base, comes to this as a power, and it's equal to that. Remember, if there's no base, we assume it's a 10, the common base. So we get this equation. So this is 1,000 is equal to 3x, and when I divide both sides by 3, I get my value of 1,000 over 3. We leave things as fractions here, so do not give me the decimal form of that. I could check that, but it will check out to give me the correct answer because it is positive there. Okay, in this problem, you are going to notice we have two logs. I'm going to highlight the logs and everything that follows it. In order for me to get one log equal to one log, I have to isolate these two things. So that 3 has to go away. If I divide it to the other side, it just goes to the other side. How I get rid of it is using that power rule. We did a problem very similar to this already. And now I have this. Now my bases are the same. They're both base 10. So this log base 10 and this log base 10 are essentially going to go away. And my equation I'm going to have is x to the third is equal to 125. If I undo this by taking the third root of both sides, and your third root button on your calculator is also under math, and I think it's like about the second or third one, but otherwise, if you plug that in, third root of 125, you'll get the answer of x equals 5. I know that's going to work because that's positive. Okay, this one's trickier because there's not just one log or two logs. There are 3 logs. If you ever have more than 2 logs, you have to condense. So we are going to take a look on this side right here where we have the multiple logs, and we're going to condense them down into 1. This is where 3.3 comes into play. So we have subtraction, and subtraction means division. So we are going to take the log, the 1 goes on the top, and the 3x minus 2 goes on the bottom. Notice I condensed this from 2 logs into 1 log. That is now equal to log of x. Now I have log with base 10 on both sides. So this and this are essentially going to simplify away and leave me with this equation. In solving this equation, I need to take and create 2 fractions, so 1 fraction is equal to 1 fraction, and then I can cross multiply and set them equal to each other. When I cross multiply this way, it's x times the quantity, 3x minus 2. Don't forget the parentheses because you need to distribute. Now what I have is this, and it's another problem in which I have an x squared and a term of x. I have a trinomial with two solutions, so I need to get one of the sides equal to 0. So I will subtract the 1 from both sides, and now I can take and factor this. This is a 3x and x. This has to be a -1. This one is a +1. You could see that's a -3x. This is a +1x, and when I add them together, I get -2x. When I set each part equal to 0, I'm going to get my first answer of -1/3 and my second answer of 1. Now, while it appears these are both my answers, again, I have to check them. If I use 1, it's okay here. Here it gets positive. I get a +1, +1. 1 works. If I use -1/3, here I'm going to get a -1, and I subtract 2, I get a -3 inside of there. This one will not work. I'm going to warn you, don't just cross the negatives off. It's what results right here. If I had something like 1 minus x in the parentheses, if I put the -1/3 in there, it'd be 1 minus -1/3, which would be 1 plus 1/3. So it would be 4/3, and that answer would actually work. So be careful, don't just automatically cross off a negative, because that's not what happens every single time. Okay, I'll do one more, then I'll give you a chance to try some of the problems. And this one has another step. Now, the log, it has only one term of log, and the log and what follows the log, what we're taking the log of, needs to be isolated, meaning the 7 and the 3 have to go over to the other side. It's just like solving an equation. We have to subtract that number first before we divide. Then we can divide. We have now isolated the log. Once it's isolated, we need to get rid of the log by writing it in exponential form. The base is going to be to that power, and it'll be equal to x. 10 to the -1/3 power is equal to x. And when I plug that into my calculator, I get 0.464. That's an approximation from my calculator. All right, this is one that you can try. Now I'll tell you, it's tricky. There's a couple ways you can do this, but you're going to notice there's multiple terms of logs. So wherever you have the multiple logs, you need to condense them on this side first. Go ahead and try it. And you have only one answer that checks out and gives you a positive, and it's x equals 1. Now, if you solve this problem an easier way, good for you, because there is an easier way in which you could have done this, but this is the way that most people would have done it at this point in time. You can also pause the video and try this one, and the thing you need to understand about this one is that natural log, remember, is just a log with base e. So that would be the same as writing the problem like this. Go ahead and give it a try. And there you go. It's pretty simple on that one. This is the best answer. If you gave me the decimal version, it's approximately that, and that's acceptable as well. All right, for this problem, first of all, I'm going to change something, and I'm going to get rid of this 3 that's right there. I don't like that 3 there. It makes the problem pretty tough. But in looking at this problem, if you want to get 1 log equal to 1 log, you would say, okay, I need to isolate the logs. That's isolated. And then you have to isolate this, meaning you have to get rid of this 5. Well, the only way you can get rid of that 5 is subtracting 5. And if you do that, it'll be gone on the right-hand side, but it's going to be moved to the left-hand side. So that truly doesn't get us anywhere. So what we have to do instead is get this log over to this side, and by adding it, doing the opposite. And then we can get that, set that equal to 5. Now that the logs are on the same side, we can condense this down into 1 log. And this has addition. Addition goes with multiplication. So now I have this. I'm going to distribute this 4 so this looks a little bit cleaner here. That gives me a 4x minus 4. And now this is down to 1 log, and once we get it down to 1 log, we can then take and write this in exponential form as doing 2 to the 5th is equal to that. So 2 to the 5th is equal to 4x minus 4, or 32 is equal to 4x minus 4. When I add 4 to both sides, I get 36 is equal to 4x, and when I divide, I get x is equal to 9. And if I check it here, it works. So my answer for this is going to be 9. So kind of tricky there. If you ever have anything added or subtracted on the side of a log, you're going to have to move all the logs to one side and condense them down. With that, you're going to practice this using the 3.4b worksheet. And make sure you get all those worksheets, 3, 4a and b done before you do C, because C is going to mix all of them up. So we'll come back tomorrow and talk about the general strategy for solving these equations. And then you'll get that assignment, and then we'll move towards the test and the review.